Here's a quick review from your research that you've been doing in class. The mole is the quantity of any chemical that has the same number of particles as 12 grams of carbon-12. We call this an SI base unit. Avogadro's number is 6.022 times 10 to the 23rd atoms, and this is how many atoms are found in 12 grams of carbon-12. Molar mass is the mass in grams of 1 mole of any substance. And finally, Avogadro's number is the number of particles in a mole of any substance. So 6.022 times 10 to the 23rd particles is equal to 1 mole of any substance. Before we can use calculations with the mole, we need to learn how to calculate molar mass. You're going to need your gold sheet with your periodic table on it in order to do this. We need to calculate the molar mass of calcium nitrate. In order to do this, we need to look up the masses of calcium, nitrogen, and oxygen. But before we do that, we further have to figure out how many atoms of each element are in the compound calcium nitrate. That's the easy part. We learned how to do that a few units ago. When we look at the formula, we see that we have 1 calcium. So 1 calcium. 1 calcium. And when we distribute the 2 into the parentheses, we have 2 nitrogens and 6 oxygens. Now looking up the masses on the periodic table, we see that the mass of 1 calcium is 40.08 grams per mole. 2 nitrogens, we take 2 times the mass off the periodic table, 14.01, and we get 28.02 grams per mole. For oxygen, oxygen's mass is 15.9995, so we just round that to 16. So we'll take 6 times 16, which gets us 96 grams. When we add all of these up together, we get 164.1 grams per mole. Another way to say this is that there are 164.1 grams of calcium nitrate equal to 1 mole. Copy this down. Alright guys, let's take a look at this problem. Please write down the example. Let's identify our known and our given and our target. Calculate the number of moles in 8.32 times 10 to the 26th power atoms of iron. This given value is our given. And our target here is the number of moles. That's our target. That's what we're going for. Now there's a couple ways that we can take a look and make a plan for our equalities, because there's no equality given here in any of this. That's because we have to know these things right here. So whether you like the map or whether you like the list of equalities, that's up to you. We have atoms, which are particles, and we have to get to moles. So if we're using the map, we're going to use Avogadro's number, 6.022 times 10 to the 23rd particles in a mole. Or if you like the equalities, 1 mole is equal to 6.022 times 10 to the 23rd particles. Okay? Alright, so that's the equality we're going to be using. So let's write that down. 1 mole is equal to 6.022 times 10 to the 23rd particles. Okay. So now we're ready to build our T-chart. And we use our given again, 8.32 times 10 to the 26th atoms, which are particles, of iron. And we're going to build the T-chart from here. We have to get rid of atoms, which are particles, so we're going to have 6.022 times 10 to the 23rd atoms of iron to 1 mole of iron. Notice I'm putting iron at every single step. We need this from here on out. You always have to have the unit and the chemical. Unit, chemical. Unit, chemical. Okay? Now for those of you still struggling with the calculator, I pulled one up here today for us to look at. And we take our given, 8.32, and we're going to use the EXP button, 26, and we're going to divide it by 6.022 EXP 23. And we hit equals. This is their calculator answer, 1,381.6007, blah, blah, blah. Now, we can only keep 3 sig figs because this is what we're starting with, 8.32. Remember, these values have an infinite number of sig figs because they're an equality or a measured value. So we can keep 1,380. 1 is less than 5, so we don't round up. So we are going to report 1,380 moles of iron. And that is our answer.